Right, so we did up to the 15th question last week. So I'm doing the 16th one, which will involve with the De Morgans, right? And after the 16th, we are going to jump into a new section where we are going to learn how these particular expressions are being derived, right? So the 16th one, this is the question. Let me take it. So the 16th, and the 16th says in square brackets, a plus b dash plus a dash plus b dash plus c, and square bracket, and at the out of the square bracket you got a dash again, right? And when it comes to the De Morgans, it will be easier if you convert the dash into the bar, people, right? Because De Morgans, we talk it with the bar relating to the bar, no? So like maybe you are comfortable, if you are comfortable with dash, so go with it, doesn't matter, right? So I'm just converting the dash into the bars. So it is giving me the total picture, like from where to where the bar is being penetrated, right? So if I convert the dash into the bars, the expression will be something like this. Now we know we can apply the De Morgans. Now, when you are going to apply the De Morgans, first resolve the biggest bar, right? So without resolving the biggest bar, you won't be able to like take things inside. Loku bar the entire expression is binded as a one, right? So it's better you decompose the big bar. So once you decompose the big bar, so a plus b bar is there already. So part of that big bar comes above it. And this plus will become a dot due to the De Morgans. And a bar plus b bar plus c is having an additional bar, which is given by the big bar. Is that clear, people?
A plus B නේද මේ ඔතන බාධක අයින් වුණා.
ඔව්. ඉස්සරහට අපිට බාධක අයින් කරන්න පුළුවන් වෙනවා. Right? So the reason is going to be the De Morgans, right? So we can say x plus y bar equals x bar dot y bar, right? So then we are going to apply the double inverse law to the first term. So it will give you a plus b dot a bar plus b bar plus c total bar. Now this gives you the double inverse law. So x double bar equals x. Now you can't apply the distributive law to these two brackets because still there is a big bar above the a bar plus b bar plus c term. So again, we have to apply the De Morgans for those things as well. So now I'm having a plus b dot, and I'm going to apply the De Morgan to this particular term. So this will become a double bar. The upper bar came from this big bar being decomposed into the three terms. So the pluses will become a dot. And b double bar will be there. Dot. C bar will be there.
So I dot එකක් ගත්තා.
I De Morgan කරනකොට දැන් අපි මෙතන පාවිච්චි කරන්නේ නිර්මාණ law එක වෙන්නේ මෙයානේ. X plus y වල total bar එක decompose වෙනකොට x bar dot y bar නේ හැදෙන්නේ. මේ අපි අර උඩ කරපු එකමයි මේ ලොකු bar එක කඩනකොට මේ plus එක මෙතනදී dot එකක් වුණානේ.
හරි.
Right. Right. So now we can apply the double inverse laws for the this A and B. Right. So how we are going to write that? We can write it like A plus B dot, it's going to be A dot B dot C bar. So the reason is still x double bar equals x. Now you can apply the distributive law. But when you are applying the distributive law, remember, now the second bracket is having dots inside that. And the first bracket is the one which has a plus. So pluses will separate the terms. That means A is a separate term, B is a separate term. But dots will not separate the term. Dots will bind the terms together. So that means this particular bracket is like a big X. Look, X make a bundle. Right? So that bundle is going to multiply with this A separately, B separately. Right? The Samaharaya Karlayoku solutions they have gone, like they have considered this A, B, and C bar as three separate terms. And you were like trying to write things like this: A dot A plus A dot B plus A dot C bar, which is wrong. Right? That is something that you do not do. Right? So always remember, if the terms are binded with a dot, so we can consider that as a one big term. If they are binded with pluses, so those are separate terms. Those are separated by the plus. Are you getting what I'm saying, people? Right. Okay. So now what actually happens is only two terms will be generated, right? How the two terms are generated? This will multiply with B and this will multiply with A again, right? That is what is happening. So generated terms will be A dot, B dot, C bar dot A plus A dot, B dot, C bar dot B. Right? And what's the reason? The distributive law. So x dot y plus z equals x dot y plus x dot z. And you may have noticed we are using the distributive law very frequently in our cases, right? In these cases, right? So now you can see here A dot, B dot, C bar dot A is there. So everything is binded by a dot, right? So that means these two A's can be considered as a one single A. So as the same way, these two B's can be considered as one single B. It is because everything is binded with a dot, right? That is a special thing over here. Special means like it's the theory, right? So now we can write it like A dot, B dot, C bar plus again A dot, B dot, C bar. So the reason is x dot x equals to x. And now we are getting the final answer, A dot B dot C bar right? It is because x plus x equals x. Why it happens like that? These two are the same or the identical terms. So when identical terms are added together, it gives the same thing. Okay, is that clear, people? So in case if you got it wrong, it's time for you to make it correct. I'll give you a minute. If you got any question, just let me know, right? Is there anyone who is copying this from the screen? Right. So then let's move to the another important part. Now, people, in the flow of this lesson, we discussed so far what are the basic and combinational gates, right? And we get to know how those things are being modified, right? Or like being created. Then we talked about drawing a particular truth table for a given expression, and the other side of it, once the expression is given, how the circuit is being created, right? And we talked about how we are going to map that particular circuit, which is drawn by the basic gates, into the universal gates. So we get to know universal gates are the NANDs and NORs. So we know if it is given, if some expression is given, we know how to draw it using the NANDs and NORs, right? Now, what I'm about to tell you is something that we are going to learn as the standard expressions. Now, hereafter, even in your exam question, these standard expressions are the expressions that they are checked mostly, right? I'm not telling you that the other expressions are not going to come, but in most of the times, they are into these standard expressions, right? Now, what are these standard expressions, right? Okay, let's discuss. So in logic gates, in Boolean algebra, actually, in Boolean algebra, we have these two types of standard expressions, which we are called SOPs and POSs. Now, yeah, some new terms, right? SOP and POS. So I'll tell you what is this SOP and POS. So the standard expressions, hold on. So the standard right? Standard expressions. Hold on, people. Yeah, it's better we say. Yeah, it's better we say expressions, not the standard one. Later we are going to talk about the standard. So there are two types of expressions. People, just give me a second. Right, sorry for that, people. So there are two types of expressions, right, which we call sum of products. Sum of products. And another one is there. Those are called product of sums, right? So two times, sum of products, product of sums, right? So the sum of product, we in short form, we call this a SOP, and product of sum, we call it a POS. Now, the sum of product means, like, we can understand it by the term or the name of it. So there are products, that means multiplications, and they are binded with a plus, right? So as an example, if I write some examples, right? Something like this. A dot B is a product, a multiplication. B dot C is a multiplication, right? And A dot C. පුතේ මට තප්පර දෙන්න මම මේ කෙනෙකුට ඩිරෙක්ෂන් එකක් කියන ගමන් ඉන්නේ, so very sorry, right, hold on. Lamai, very sorry, Lamai. Right. Okay. So we were in here, A dot B and B dot C and A dot C. These are called products. So this is going to be connected with pluses, right? So this is called sum of products, right? And how the product of sum can be implemented, it's like this, right? So I can say A plus B. So this is a sum. B plus C, it is a sum. And C plus A, it is a sum. So these are sums connected by a multiplication. So these are called product of sums, right? So what we have to do is, like, what we have to recognize is the pattern. Sum of products, the product of sums, right? Okay, people, just have this on your book. I'll be right back in a minute. Right, people. Okay, the problem is solved now, right? Okay, so and below this I'm going to write you another expression. Later I'll tell you what's the difference of these two things, right? So now look at this expression that I'm writing, right? So I'm writing a dot b dot c bar plus a dot b bar dot c, right? Plus a dot b dot c bar, right? So these two expressions, if you compare the above expression and the lower expression, the below expression, there are differences. What is the difference of the above expression and the lower expression? What can you recognize? Think about the, like, compare the each and every term. Compare the each and every term. Right, you can recognize. Can you recognize, like, if you take these terms of this SOP, this term has now the entire term has three different variables, which is A, B, and C, right? And if you take a one particular term, first term has A and B only, second term has B and C only, third term has A and C only. But if you look through the second expression, what's the difference? If you take the total expression, again, you can find only three different variables, which is A, B, and C, right?
terms තුනම එකයි නේද?
terms තුනම එකයි කියන එක නෙවෙයි. terms තුනේම අපිට
ඒක විදියට ලියවිලා තියෙනවා.
එකක්ම දකින්න හම්බෙනවා. Each and every term contains all the variables. A, B, and C මොන විදිහකින් හරි ඒ term එකක් ඇතුළේ ඉන්නවා. Right? So the expressions which has these type of terms, and all the terms should be on that pattern. If all the terms of an expression contains all the variables of the expression, we call it a standard SOP. A standard SOP, right? If it is not, if it is something like this, then මේ හැම term එකක්ම ගත්තම මේ හැම term එකකම හැම variable එකක්ම නැහැ, right? So if the expression got any single term, like which is not contain all the variables, we call it a non-standard SOP. එතකොට standard වෙන්න නම් හැම term එකකම හැම variable එකක්ම තියෙන්න ඕනේ. එක term එකක හරි variable එකක් miss වුණොත් කවුරු හරි මුළු expression එකෙම තියෙන, එයා non-standard වෙනවා. තේරුණාද?
සදා පොඩ්ඩක් කියන්න. explain කරන්න.
ඒ කියන්නේ නිර්මාණ දැන් පහළ තියෙන එකේ පහළ තියෙන expression එකේ හැම term එකක්ම කියලා කියන්නේ මේ හැම පදයක්ම කියන එක, මේ හැම පදයකම එතකොට හැම ගුණිතයකම SOP එකක නම් මුළු expression එකම බැලුවොත් ඒකේ තියෙන්නේ අකුරු ಜಾති තුනයිනේ. A අකුරයි, B අකුරයි, C අකුරයි total expression එක. එතකොට මේ හැම term එකකම ඒ අකුරු තුනම තියෙනවා. right? එතකොට එහෙම තියෙන terms නම් මුළු expression එකේම තියෙන්නේ. අපි ඒක කියනවා standard expression එකක් කියලා. එහෙම නොවන ඒවාට අපි කියනවා non standard expressions කියලා. තේරුණාද?
හරි හරි.
right?
එතකොට SOP හැම එකක්ම standard
නෑනේ, SOP හැම එකක්ම standard නොවී තියෙන පුළුවන් නෙවෙයි නිර්මාණ. මම දැන් මේ මෙතනම ලියලා තියෙනවානේ standard වෙන එකකුයි standard නොවන එකකුයි.
හරි සර්.
දැන් මම මේ උඩ ලියලා තියෙන එක්කෙනා ස්ටෑන්ඩඩ් නොවන SOP එක. යට ලියලා තියෙන එක්කෙනා ස්ටෑන්ඩඩ් SOP එක. Right. Okay, so the similar way, the POS can also be a standard one, and POS also can contain standard ones and the non-standard ones. Right? මෙතන මේ ඊට තියාගත්ත මේ දෙක හරියට ලියා ගන්න. So this is called non-standard expression. Right? So this is called the standard expression. Right? So likewise, if I write A plus B bar plus C dot A bar plus B plus C dot A plus B plus C bar, and that is also a standard expression. Now you can understand, right? So this is a non-standard expression, right? People, I want you to have some bars in your non-standard one. නැත්තම් ඔයගොල්ලෝ වරදවා තේරුම් ගන්න පුළුවන් මේ bars නැති වෙන්න ඕන කියලා non-standard වල. ඒක නිසා මෙන්න මේ විදිහට modify කරගන්න expressions දෙක. Like this, right? And complete the other two as well. So the big picture, the full picture is we have expressions. Those are being categorized into the SOPs and POS. So we have standard POSs, we have non-standard POSs, right? Okay, complete the diagram.
සර් බාස් නැති වෙන්න ඕනේ කිව්ව මොකද?
නෑ බාස් නැති වෙන්න ඕනේ කියලා නෙවෙයි නිර්මාණ මං කිව්වේ. මම මේ බාස් ටික දැම්මේ සමහර වෙලාවට ඔයගොල්ලෝ මේ උඩ කියන්නේ මං කලින් තිබුණේ බාස් මුකුත් දාලා නැතුවනේ. ඔගොල්ලෝ පස්සේ බලනකොට ඔළුවට අයිඩියා එකක් එයි කියලා මේ non standard ඒ වගේ බාස් නැහැ කියලා වගේ අයිඩියා එකක් ආවොත් කියලා තමයි මම ওই බාස් ටික දාගන්න කියලා කිව්වේ. right? ඒ changes ටික කරගන්න මම ওই උඩ පේලියට changes ටික කරගත්තා. ඔයගොල්ලෝ ලියාගත්ත එකේ B වලට උඩින් බා එක දාලා ඒ ටික දාලා තියෙනවා. ඒ ටික දාගන්න මේ විදිහට. right? People, if you got any doubts, just let me know, right? If there is any unclear places.
සර් දැන් ඒක ස්ටෑන්ඩඩ් එක දැන් ABC කියලාම අපි ඔතන ඔක්කොගෙම ලියලා තියෙන්නේ.
ඔව්.
BACCBA එහෙම වෙන්න
එහෙම
පුළුවන් B
ගැටලුවක්
නම්බර
නැහැ. එහෙම
දාලා.
ගැටලුවක් නැහැ. මොකක් හරි ටර්ම් එක කියන්නේ අපි සම්පූර්ණ එක්ස්ප්‍රෙෂන් එක ගත්තම ඒ එක්ස්ප්‍රෙෂන් එකේ වේරියබල්ස් තියෙනවා නම් තුනක් හැම පදයකම ඒ වේරියබල්ස් තුන ඉන්න ඕනේ මොකක් හෝ විදිහකට මොකක් හෝ පිළිවෙලකට. Clear the Nirmana?
හරි සර් හරි.
Right. People just let me know when you are done. Right. තාම ලියන කවුරු හරි ඉන්නවද? Okay. Right. So let's move forward. Now, okay. Now, when we are given a particular standard, non-standard expression, there are ways that we can convert it into a standard expression. Right now, even though this is in your syllabus, this is there in your syllabus, but it's not, it has not been tested in the examination. So I'll just show you how the things are doing. You just follow, right? We are not going to practice it much. Look what a highlight vela nathi nisa, but let's get to know how this is happens, right? So now I'll take a very simple expressions. ඔයගලගේ tute එකෙත් මේ කියන දේවල් ටික මේ විදිහටම තියෙනවා, but I'll show you how it happens, right? So I'll take standardizing a non-standard SOP. Right? I'll take a simple example over here, a simple. So I'll take A dot B plus B dot C, right? Let's take this as F equals. Then SOP එකක් කියන එක indicate කරන්න අපි මෙහෙම ලියනවා F SOP A dot B plus B dot C. So now we can understand this is a non-standard one. So first term is missing C and the second term is missing A, right? Okay, now the logic is if we want to, then now the requirement is we need to add C to the first term. C wa පළවෙනි term එකට දාගන්න ඕනේ. ඒක තමයි අපේ requirement. Now the terms, if you take the terms, they are in multiplications. Multiplications විදිහට තමයි ඒගොල්ලෝ තියෙන්නේ. So if you think mathematically, what is the number that you can use? What is the number that you can use to effect or to add into a, like to multiply a term which will not change its value? Term එකේ අගය වෙනස් කරන්නේ නැතුව multiply කරන්න පුළුවන් number එක මොකක්ද? මොකද මේ terms තියෙන්නේ multiplications විදිහට. So we have to apply a multiplication. term එකක value එක change නොවෙන්න multiply කරන්න පුළුවන් value එක මොකක්ද?
B ගැන කියන්නේ
නෑ කියන්නේ මේ මම කියන්නේ variable එකක් නෙවෙයි නිර්මාණ මම අහන්නේ අගයක් ගැන. මොකක් හරි දැන් මොකක් හරි දෙයක අගය වෙනස් නොවෙන්න අපිට වැඩි
1
ගන්න පුළුවන් අගය. yes 1 නේද? එකෙන් ගුණ කරාම ඒ අගයම තමයි අපිට එන්නේ. right? So the technique is we use 1 a dot b dot 1. Since we are missing one variable, we say it's dot 1. So we can apply the same theory to the b dot c as well. The b dot c wala a miss vela tiyena, so we put a 1. Now in Boolean laws, you know x plus x bar equals 1. Right? We know this theory now. Right? So what we are doing is we represent this 1 as in the form of x plus x bar. X plus x bar ආකාරයට අපි මේ එක ලියා ගන්නවා. ලියා ගන්නකොට we use the missing variable. Right? That means a dot b. For 1 we write c plus c bar. And in the second term, it's b dot c. So missing variable is a. We write 1 as a plus a bar. Did you get this? Yes? Right, great. Now you apply the distributive law. A dot b dot c plus a dot b dot c bar. Right? C plus c bar bracket is solved. Then another plus, we can say b dot c dot a plus b dot c dot a bar. Right? Then now if you consider the expression that we got here has 4 terms and each and every term contains a, b and c. So it is been standardized, right? But still there are some works to do. Sometimes you can finalize your answer from this step. But if you look closely, you can see this term and this term represents the same thing. Right? This is ABC and that is BCA. So that means ABC. We know it can be changed using the associative laws. Right? So instead of writing two things, because we know x plus x is equals to x, so we can write a dot b dot c, right, which represents these two terms, plus a dot b dot c bar, plus I'll write the last term as a bar dot b dot c. Right? So this will give you the standardized SOP. තේරුණාද? Right, great. People, I want you to copy this down and I'm going to give you a simple question regarding this. So I want you to do that and send me the answer as well. So here comes the question. You can copy it down and write the question below. People, if you got any questions, just let me know, right?
සර් මේ අර මේ ඩීමෝගන්ස් දැම්මයින් පස්සේ එකක්වත් සමාන නැත්නම් වේරියබල්ස් කොහොමද කරන්නේ?
එතකොට අතනින් ඉවර කරනවා නිර්මාණ. එකක්
හරි.
සමාන නැත්නම් ඒක තැනින් ඉවර කරා. එතන අර මේ පද ටික පිළිවෙලකට ලියලා පෙන්වුවට කමක් නැහැ. ඔය BCA තියෙන ඒවා ABC කියලා ලියලා එහෙම පිළිවෙලකට අර එතකොට නීට්නේ වැඩේ. එහෙම ලියලා ඉවර කරන්නයි තියෙන්නේ. Okay, Lalinti, I received yours. Let me see. Right, okay. Yes. Yes, very good. Yes, very good, Dua. Very good. Right. Right, others, you should send me an answer.
සර් මම ඒව ආන්සර්.
Right, hold on, let me see. Let me see. Yes, Nirmana. Yes, okay. Right, okay. Yes, that's right. Okay. Yes. Yes, that is correct, Pura. Very good. How about others? Sachintani, yes, let me see that. Okay. You don't have a double bar on P at the last term, neither. Where the line is print to Right. Yes, that is correct, Dua. That is correct. Good. Nikini, Pahanmi, how about you two? Apahanmi, I received yours. Let me see, Dua. Okay, kobaran podi tanak ඇස්සලා තියෙනවා. පහන් මිදුව පුතේ ඔයාගේ ෆස්ට් බ්‍රැකට් එක සෝල්ව් කරනකොට දුව ඔයා එක ටර්ම් එකයි පුතේ අරගෙන තියෙන්නේ. PQ bar R එතකොට ඒක අර R plus R bar එක ඇතුලේ තියෙන R එක තමයි ගුණ වෙන්නේ. ඊට පස්සේ R bar එක එන එකකුත් තියෙන්න ඕනේ දුව. එතකොට P dot Q bar dot R bar කියලා එකකුත් එනවා. තේරුණාද පහන්නේ? Same goes with the Q dot R bar. Q dot R bar dot P plus Q dot R bar dot P bar. Right? එතන change කරගන්න දුව. හරි විදිහට හදාගන්න. Nikini, I received yours. Let me see. Right, okay. Right, yes, yes. Yes, so that's correct. Yes, Nikini. Very good, very good. Right. All right, so let's go to the other side, or like standardizing a non-standard POS, right? So something similar technique. I'm not going to do this because you guys have done it quite okay. අහන් විදුව මට correction එක කරලා එවන්න දුව, right? I'll go through. Right, so the next one is standardizing non-standard POS, product of some, right? So let me take an example. So I'll take F, this is a POS, equals A plus B bar dot B bar plus C. Right? So this is a non-standard one. We can understand because first term is missing with C, second term is missing with A. So now if you consider the terms, they are bounded or they are like connected with pluses. Plus වලින් connected. So I'll ask the same question again. What is the value that you can add to a term without changing its value, its original value? Term එකේ original value එක වෙනස් නොවෙන්න add කරන්න පුළුවන් කවුද? Lalindi, think a little. It's a C.
value එක දාන්නේ නැත්තම් letter එකද?
මම කියන්නේ නිර්මාණ මේ A plus B bar කියලා value එක පුතේ අහන්නේ. value එක A plus B bar කියලා term එකක් තියෙනවනේ. එයාගේ අගය වෙනස් නොවෙන්න එයාට එකතු කරන්න පුළුවන් අගය මොකක්ද? right, එතන අහන්නේ අගය.
එකතු ගන්න පුළුවන් ඒකට බිඳුව නේද?
බිඳුව. අන්න right. බිඳුවක් තමයි එකතු කරන්න ඕනේ. So I'm going to write that. So A plus B bar, since I'm missing C, I'm going to add a 1 0. එතකොට එක්කෙනෙක් අඩු නම් 1 0 එකක් දානවා, දෙන්නෙක් අඩු නම් 0 plus 0 කියලා දානවා. right? So B bar plus C plus another 0 because A is missing. And in Boolean laws, we know x dot x bar is equals to 0. We know about this now. So what we are doing is we replace the 0 from x dot x bar 4. But when we are replacing it, we use the missing variable. Right? So here we go. A plus B bar plus C dot C bar. And dot B bar plus C plus A dot A bar. Are you getting this up to this point? All right. Okay, so now I am going to use the second law of distributive law. Now, what is the second law of the distributive law? Second law is something like this. We wrote it like x plus y dot z. This can be written as how? X plus y dot x plus z. X plus y dot x plus z. Right? Now we know that. අපි එතෙන්දි කරේ මේ x plus එකත් එක්ක එක සැරයකට y වාර ගත්තා එක සැරයකට z වගත්තා. Right? So this dot stays in between the brackets. So the same thing I'm going to do to this particular brackets, but when we are doing that, we consider a plus b bar. Like if you consider the first bracket, we consider a plus b bar as x, then a plus c dot c bar as y dot z. Right? No homai api map karani. Right? A plus b bar එක අපි අරගන්නවා x කියලා, c dot c bar එක තමයි y dot z කියලා consider කරන්නේ. Right? So by considering that, how we are going to write this? So it's going to make me two brackets, a plus b bar plus c. It's going to be a one bracket, like x plus y. Dot a plus b bar plus c bar is going to be the other bracket. Right? So the first bracket decomposes into two brackets. Are you clear with it, people?
එතකොට ඕනම තැනක කියන්නේ දැන් ඔය විදිහට තිබ්බොත් ඒ කියන්නේ ඕකට x අරන් අරකට y dot z කියන එකද කියන්නේ දැන් එකම variable එකක් තියෙන තැනට අපි y dot z කියන එකනේ දැම්මේ. සාමාන්‍ය තැනටනේ සහරණම් x එන්න ඕනේ.
කොතනද පුතේ?
එහෙනම් a dot b bar කියන්නේ variables දෙකන් එකිනෙකට වෙනස්.
ඔව්.
c dot c bar කියන්නේ එකම variable එකනේ.
ඔව් c dot c bar කියන්නේ එකම එකිනා උනාට අපි මෙතනදී consider කරන්නේ දෙන්නෙක් විදිහට.
හරි ඒක තමයි.
තේරුණා?
හරි.
a plus b bar කියන එක බන්ඩල් එකක් කියලා අපි අරගන්නවා.
සර් බා එක අයින් වුණේ කොතනද?
බා එක අයින් වෙන්නේ නැහැ පුතේ. වෙන්නේ මේ a plus b bar එක වතාවක c connect වෙනවා. Right? තව වතාවක
c dot c bar කියලා තියෙනවානේ.
ඔව් මෙතන තියෙන c bar. තේරුණාද? එක වතාවක c connect වෙනවා තව වතාවකදී c bar connect වෙනවා. තේරුණා?
එතකොට a bar
a bar කොහෙද බයි?
a dot a bar කියලා වෙනම එකක් තියෙනවා.
ඒකට අපි වෙනම ලියමු. තාම ලියුවේ නැහැ.
හරි.
Hurry. So the next thing is a second bracket. Now in the second bracket, again these two works as x, these two works as y dot z. Right? So how it happens? B bar plus c plus a dot b bar plus c plus a bar. Right? So now if you think about, if you focus the final answer, it has four brackets and each and every bracket contains all the variables in the expression, which is a and b and c. So here we got a POS, and do we have any identical ones? We have, right? This one and this one. Here we should have a dot again. Those two are same. right? A plus B bar plus C. So I'm going to write one particular brackets on behalf of them, right? So we can write it A plus B bar plus C, A plus B bar plus C. So for these two, dot A plus B bar plus C bar dot A bar plus B bar plus C as the last one. So this is going to be my standardized POS, right? Okay, copy it down here. Oops, hold on. And this square part, it is about the theories that we use, right? It's not the part of the question or the part of the calculation, right? And below, I'm going to write a one, so you have to try it as usual. So here comes the question. Standardize right. That's going to be your question. Right, the question is there. You can get the question and send it to me. Okay, Nikini, I received yours. And Larindi, I received yours too. Nirmana, I received yours as well. Let me see, you're right, okay, okay. And Nikini, your like Q bar is missing at the second term, from the second term, Puta. එතන ගැටලුවක් වෙන්න පුළුවන්, right? ඒකයි බලන්න second line එකේදී Q bar එක දුවා ඉතින් miss වෙලා තියෙනවා. Right? Redo and see. I think the answer is going to change. And Lindy, let me see. Okay, right. Okay. Right, okay. Yes, right, okay. That's correct. That's the answer. Very good. Nirmana, Kavaramu. Right, okay. Right. Okay. Yes. Very good, Nirmana. Sachintani. Yes, that is the answer, Dua. Very good. And Pahanmi, how about you? Oh, Pahanmi is not in the room. Pahanmi disconnected. Never mind. All right, great people, great. Nikini, yes, Dua, that's correct. Now it is correct. Yes. Very good, people. Right. So that is the way that you are going to standardize the non-standard SOPs and the POS, right? So remember the techniques. I'm not going to do a lot of questions regarding this, right? Since it is given less focus in the syllabus, right? So let's move to the other part, right? Okay, now we are going to talk about the conversions in between the POS and SOP. Again, this is a less focused thing in the syllabus, but it is there in the syllabus. So we can convert a particular SOP into a POS as well as a POS into a SOP. But you should remember, when you are doing these conversions, when you convert a particular SOP into a POS, you will be having some particular answer. But when you are converting a particular, the same particular POS into the SOP, you may not receive the original one that you had, right? මේ conversion එක කරන්න පුළුවන්. POS එකක්, I'm sorry, right? You can convert a POS into a SOP as well as SOP into POS. So when you are doing the conversion, it's going to represent the same function, right? එකම එක්කෙනා තමයි SOP nature එකෙන් එනවා, POS nature එකෙන් එනවා, but it's going to, at the end of the day, it's going to produce you the same value, right? But sometimes you will see when you represent the POS into the SOP as well as SOP into the POS, then ඔයා මේ පැත්තේ x කියන term එක මේ පැත්තට convert කරාම y ඇවිල්ලා same y මේ පැත්තට convert කරාම මේ x නැතුව වෙන term එකක් එන්න පුළුවන්. But it is the nature, ඒක තමයි විදිහ. But ultimately, if you match it to a standardized SOP or a POS, your answer going to convince you it is the very same. Right? එහෙම වෙන්න පුළුවන් කියන එකයි මම මේ ඔයගලන්ට කියන්නේ. Right? Changes එන්න පුළුවන්. හැබැයි ඒක සමහර වෙලාවට it's not the same equation that you are receiving. හැබැයි ඒක standardize කරාම ඔයාලට තේරෙවි. ඊතනකො x convert කරාම SOP එකට y වුණා, then y convert කරාම ඔයාලට z කියලා answer එකක් ආවේ. But this මේ දෙන standardize කරාම you will see both are showing the same value or the same expression, right? අපි ඒ තරම් දුරට යන්නේ නැහැ මෙතන, but just keep that in mind, right? So anyway, these two expressions are like for the same, if the same PO is converted to the SOP, both the expressions are going to represent the same value. It will be definitely representing two different expressions. මොකද එකක තියෙන්නේ products වල sum එකක්, අනිත් එකේ තියෙන්නේ sums වල product එකක්. So definitely nature එක වෙනස් වෙන්නද. But ultimately the end value is going to be the same. ඒ කියන්නේ ඔයගොල්ලෝ දැන් දන්නවනේ expression එකකින් truth table එක create කරගන්න. So truth table එක create කරාම final answer එක විදිහට එන ones and zeros column එකේ ones and zeros රටාව identical. POS එකෙත් identical, SOP එකෙත් identical. Right? For the same expression. Right? Okay, so I'll show you how the things are happening, right? So then you can understand how it happens. Right, so now we are going to talk about, first I'm going to talk about POS into SOP conversion because it is easy for us to understand. POS converting POS into a SOP, right? So I'll take an example, a simple example, right? So this is the example that I'm going to take. X dot y plus z, right? Then this is a POS. X is a term alone and y dot z is a term alone, right? So මෙතන නම් තියෙන්නේ sum එකක්, අපිට මෙතන sum එකක් පේන්නේ නැහැ because there is only one term, but at the end of the day we can say it as it is as a POS. This is a non-standard one, right? That doesn't matter. Right? And now what I'm going to do is to convert this into a SOP. It's a very simple thing that I need to do, right? So like I can say apply the distributive law, right? A simple thing to do. So what will happen? If we create x dot y plus x dot z, right? So now you can see these are products, and it is binded with a plus. right? So this is a POS and this is a SOP, right? It's better I say F equals. Right? Simple as that, right? POS එක තියෙනකොට නිකම්ම distributive law එක apply කරාම SOP එක generate වෙනවා. Right? Are you clear with this, people? Right, great. Okay.
එතකොට අපිට මේ distributive විතරද උතන apply කරන්න පුළුවන්.
ඔව් ඒ කියන්නේ නිර්මාණ අපි distributive apply කරාම අපේ වරහන් ටික සුළු වෙනවනේ. එතකොට නිකම්ම SOP කියන තැනට එනවා. අපි මෙයාව එතනින් එහාට simplify කරන්න යන්නේ නැහැ.
එතකොට ඔකත් non standardized නේද? මොකද
Oh,
X5
but non-standard. Yes, yes, yes. ඒක ගැටලුවක් නැහැ. අපිට මේ nature එක ගන්න ඕනේ. ස්වභාවයයි ගන්න ඕනේ. Right, මෙතන? Excuse me. Right now, here I'm going to do the other conversion. Converting SOP into a POS. Right? So we can take the right. I'm going to take the very similar SOP that I received, x dot y plus x dot z. Right? So the first thing that I'm going to do over here, right? There are short ways. Short ways can make a specific. Right? Then ogolo මේක දිහා බලලා එකපාරට distributive එකේ reverse එක apply කරලා අර POS එක ගන්න පුළුවන්. But it's not going to apply for all the places. Right? මම ඔය කතන්දරේ වෙන නිසාම අපිට ඉන්නකො මේක යුනිවර්සල් විදිහකට ඔයගලන්ට ඇප්ලයි කරන්න අපිට ඉන්නමයි Oh, come on, අපි ඔය විදිහ මේක ලේසි. නැත්නම් ඔයගලන්ට ඒක උමනාවට වඩා complex වෙනවා, right? So this is the general way of doing this, right? සමහර වෙලාවට ඔයගලන්ට demob boolean laws වල තියෙනවා straight away apply කරලා answer එකට යන්න පුළුවන්. But generally this is what we do, right? So the first thing that we are doing is taking the complement. Taking the complement of both sides. So taking the complement means what? I'm going to take f bar over here. So I'm taking x dot y plus x dot z and the total bar. Right? Since it is a equation, we can do this. Right? So taking the complement. Then we are going to apply the De Morgans to the complemented side. Apply the De Morgan and simplified. Now this is the important part. Simplified the answer by maintaining SOP form. SOP form in it. Right? කියන්නේ डी මෝගන් දාලා simplify කරනකොට මේ SOP form එක maintain වෙන විදිහට කරන්න. කියන්නේ අපිට simplify කරලා SOP එකක් ගාවට වෙනකන් SOP type එකක් වගේ වෙනකන් maintain කරගන්න ඕනේ. So what happens? The expression that we have is x bar equals x dot y plus x dot z total bar. So we apply De Morgan's. So this is going to give you x dot y bar dot x dot z bar. And later we apply De Morgan again. So it's going to be x bar plus y bar. This dot continues. X bar plus z. Right? So I had said the answer by maintaining SOP form. So this is not in SOP form. This is a POS form. So I'm going to apply the distributive law. So it's going to give me x bar dot x bar plus x bar dot z bar plus y bar dot x bar plus y bar dot z bar. So we know x bar dot x bar equals x bar plus x bar dot z bar plus y bar dot x bar plus y bar dot z bar. Right? So if you look closely, the first three things has x bar as a common factor. So take x bar out. So it says 1 plus z bar plus y bar plus y bar dot z bar. So this means this is equals to a 1. So x bar dot 1 plus y bar dot z bar. Right? So that gives you x bar plus y bar dot z bar over here. Right? So this is what? Still this is f bar is equals to this thing. මොකද අපි complement කරලා තමයි මේ simplification එක කරගෙන ආවේ. So now what you have to do is take complement again. So taking complement again will make this f double bar and we'll make this x bar plus y bar dot z bar another bar. Right? So the final one is like apply the De Morgan to take the POS. So f double bar means this, and this gives you f equals, this becomes x double bar plus will become a dot and y bar dot z bar's total bar will be there. And now x double bar means x dot y bar dot z bar means y double bar plus z double bar. That's how you apply the De Morgans. So this will gives you x dot y plus z. The SO, the POS, right? So you can see there are 4 steps that I have followed through, right? First, I have take the complement, then I have apply the De Morgan and maintaining the answer as a SOP. Then I complement it again. Then we apply the De Morgans to take the particular POS. Yeah. Is that clear, people? Right? දැන් මේක ඔයගලන්ගේ ටියුට් එකේ තියෙනවා, right? But I want you to take this onto your book as well. මොකද ඒක පොඩි practice එකක් වෙයි, right? I'll move the screen little by little. Right? We are not going to do a lot of questions from this, just to know how these things are happening. Right? Okay, here it goes. So start writing. people, if you are missing anything, just let me know, right?
සර් මෙතන මේ x bar අර සර් මේ 1 plus z bar plus y bar කියලා එකතු කරලා තියෙන්නේ. එතකොට ඒ කියන්නේ ඔටෝමැටිකලිම z bar y bar අයින් වෙනවද?
ඔව් ඇයි නිර්මාණ එකට මොකක් හරි එකක් එකතු වුණාම උත්තරේ එකයිනේ. 1 plus x කියලා කියන්නේ 1 නේ. x ට එකක් එකතු වුණාම එකයි කියලානේ අපි මේ බූලියන් ලෝස් වල අරගෙන තියෙන්නේ.
හරි සර්.
right ඒකෙන් තමයි ක්ලියර් වෙන්නේ. ඒතර 1 plus z bar 1 වෙනවා. ඊට පස්සේ 1 plus y bar තියෙන එකත් 1 වෙනවා. ඒක නිසා සම්පූර්ණ එකම 1 කියලා තමයි අරන් තියෙන්නේ. All right. Once you are done with this, you can leave the session. Right. Thank you very much, everyone. So next week, I'm going to start the operating system as well. So please collect your tubes. Right. So once you are done, you can leave. Right. Thank you very much again. Right. Okay, Nikini. Thank you.